Welcome back. This week we're talking about switches. We've used switches in the past in our analog circuits just to carry a current completing a circuit, usually a simple series circuit, something like that. This week what we'll be doing is using switches to interface with the Arduino. On this circuit I've got two switches set up. I've got a simple momentary push button switch and a tilt switch. So mine looks gold, some look black. It's just a cylinder with two leads going to it. I have it connected back to the board with these little jumpers, but depending on orientation it'll complete or disconnect a switch. You can usually hear a little ball rattling around in there. That's what's rolling around to complete the circuit. And in this circuit in particular, both switches have one lead that's connected back to the board, these white wires. The other end of the switch is going back to ground. For the momentary, it's through this little jumper wire. For the tilt switch, it's the other lead of this is going back to ground on the breadboard, and then one black wire is leading back to any ground on the Arduino. Outside of that, we've got this red wire coming from the board through a 220 ohm resistor through this red LED back to ground. So that's the setup of this. We've got two switches, white wires connecting back to the sensing pins on the Arduino, the other ends going back to ground, and then one simple series circuit with this red wire for the LED. So let's take a look at the code. So here we have the code for our push button and tilt switches. I've neglected or purposefully not made any global variables. What we're doing right now is we're just going to have some local variables that get declared in the loop and just used in the loop. Doesn't necessarily need to be declared globally, but in this particular instance I'm just going to declare it locally here and let it use it inside of the loop without having to know what it is anywhere outside of this loop. So beginning at the beginning, in the setup we're declaring the pin modes for our 3 pins. 2 of them are for the switches, 1 of them is for the LED. Number 3 is our output for the LED. The other 2, this is the new thing. We're going to be using the input pull-up declaration for these pins. The reason we're doing this is that the Arduino has built-in pull-up resistors inside of itself that we can use whenever we want through this declaration. What this does is this means that pins 5 and 2 will always read a high voltage when nothing's happening. Those pull-up resistors pull up the voltage at those pins to 5 volts. And what we're going to be doing is using our switches to drag that voltage to ground reading 0 or low. And in that process, we're sort of making our circuit building simpler. We don't have to use those extra resistors in our physical circuit. They're already in the board, and we're engaging them with this input pull-up command. So if we remember what those circuits looked like, both switches were connected to ground through the switch from the Arduino, through the white wires. So every time we push the switch, that's connecting it to ground, that's reading 0 volts or low voltage. So, inside the loop, we have 2 integers, the push button value, which is digitally reading pin 2, and the tilt button or tilt switch value, which is digitally reading pin 5. We're going to print those so we can see what they look like, and then we have a couple of if statements. Now, remember in its native state, because of that input pull-up resistor, the values are going to be high natively when we're doing nothing. So, this if statement is asking if push value is equal to, remember 2 equals is asking the question, or 2 vertical bars, tilt value is equal to high. So, when nothing's happening, when they're both high, we're going to digitally write the LED pin low. We're going to have it turned off. Our next option, if the push value is low or the tilt value is low, either or, we will write it high. We will turn on that LED. And now here's a third statement. If the value is low, for both of them. So double ampersand signs. So if the push button value is low and, not or, and the tilt value is low, do something else. And we haven't seen that yet. So we're going to digitally write it on and off a couple of times really quickly. So let's go back to the circuit and see what happens when we push each one individually and then at the same time. So now that we've taken a look at the code, we know that pushing any one of these or engaging the switch individually does one thing, depending on rotation in this particular instance. But if we push them both simultaneously, we have a whole new third function, let's say, as we saw declared in the if statement at the end of our code. So we know that engaging any one turns it on, but both of them makes it blink. And again, right now we're just using LEDs as examples for anything. This could be motors turning in particular ways. This could be varying lights going off in varying patterns. There's no end to the amount of things we can do with switches. We're just giving it different ways to understand that we want things to change. So have fun. So here's the circuit for our next switch operation. We're going to be working with capacitance switches. So these are switches you might have seen in like a lamp potentially, and we're basically going to be building this ourselves with the Arduino, some high ohm resistors, and anything conductive. In this case, I've got 3 different pieces of foil connected with jumper wires just taped on, just metal to metal connection, back to the board, and each one controls a different light based on the capacitance that the Arduino is sensing. Now, what's capacitance? Well, capacitance is the ability of a electric component or any object or body like ourselves to store a little bit of electric charge. So what we're doing here is we're using 3 very high ohm resistors in the circuit, 4.7 mega ohms, 10 mega ohms, and 1 mega ohm, to make a comparison inside of the board. When we're not doing anything, it's reading a voltage, and as we engage with these metal parts, we're actually adding a little bit of voltage to the circuit from ourselves. The Arduino senses that, and when it passes a certain threshold that we set in the code, it engages whatever we want, in this case, lights. Now this could also be using anything metal to connect myself back to the circuit, or making an object part of the circuit by connecting it back. So this piece of foil right now is a piece of foil. It could be a wrench, it could be a steel sculpture, it could be a handrail. There's any number of things that it could be. But I'm going to zoom this in a little bit just on the circuit. We'll talk about that very quickly and then go back into the code. So here's our circuit setup. We've got our 3 LEDs on the bottom left of the board, the short leg, the negative side going back to the negative rail of the board, and that's connected with this black jumper back to any ground on the board. There's close-up photos of all this in the class drive for this particular lesson if you need a little bit closer of a look. Each one of these LEDs is running through a 220 ohm resistor back to the board. I've got the wires color-coded per LED, and those are going back to 10, 11, and 12 respectively, green, yellow, red. That's one part of the circuit. That's the simpler part. The other side here, we have our 3 high ohm resistors, 4.7 mega ohms, 10 mega ohms, 1 mega ohm. These are just ones I'm using in this example. You can change this up as much as you want. The higher the value of that resistor, the more sensitive it is. So you could be doing this with a 2K resistor or a few resistors in series to up their overall resistance. Whatever you want to do, set those resistors up with whatever components you have. They're all sharing one row, which is going back to the board with this orange jumper. I believe that's pin 4, yep. So each side of each of those resistors is connected together. The other end is each connected to that blue jumper wire It goes back to pins 2, 6, and 8, respectively. That's connected with the white wires to our pieces of foil, our tools, whatever metal conductive objects we have. The bigger that object, the larger of a range of an area you can actually start to sense through. So we'll take a look at the code and a little bit more at the circuit in just a second. So before we dig into the capacitive switch, capacitive sensor code, one thing we have to do to our Arduino program is actually download the libraries for the board to understand. It doesn't come native with this information, so we got to teach the Arduino a little bit by managing the libraries. So under the Tools tab, you can manage our libraries. Once you click that, it'll drag up a window here that will download and update whatever libraries I currently have installed into my Arduino IDE. And once it's done updating, I can search for new libraries, whatever I want, really. In this sense, we'll be searching for the capacitive sensor library. So once it's updated in the upper right, I'm just going to start typing capacitive sensor, and it'll search. And right here, the capacitive sensor by Paul Badger, version 051, and install. Once you click install, it'll install it automatically. It'll put all the folders right where you need them, and you don't have to do anything outside of that. So it'll also be installing examples that we can check out. Once that's all done, you can X that window out. And in the examples, now at the bottom, we'll have examples from custom libraries. This is a sketch we can use to check things out. The other thing we can do is use our sketchbook and check out, let's see, the first capacitance code. So this code will enlarge. We've got a couple of things. At the top, we've got the hashtag include the library. This is part of what we just downloaded and included into our IDE, which makes sense of all this nonsense here. I've got a little bit of type in here. I've ripped this from Paul Badger's work and altered it a bit, but you can experiment with resistors between 50K and 50 mega ohms for this particular instance. And over here, it's telling us what pins are the capacitive sensing pins. You'll see they all share pin 4 as a common. Remember that orange wire going back to the board. And then the other ends of those, the other pins for these pairs, are what's connected back to the other leg of the resistors, the 10 mega ohm, 1 mega ohm, whatever your choice is. We've declared our integers for the green, yellow, and red LEDs. We've set them up as outputs. There's no input declaration, as it were, for the capacitive sensors. That's included in the library. And down here in the loop, this is the custom language that the library includes that tells it basically, hey, read these things, do some work, you don't need to worry about it. It's going to print these totals so we can look at the numbers. And then down here, we've got a section I've made that says turning on. So these are the thresholds. So for total 1, total 2, and total 3, each of which would be the readings from the capacitance sensors, we've set a threshold. Right here, 10,000, 1,800, and when it goes over that threshold, it'll write the appropriate light high. When it's below the threshold, these if conditions, it'll write it low, turn it off. So turning it on is happening up here. If it goes above the threshold that we've set, and turning it off is down here, where it's going below the threshold that we've set. So this is what's giving the Arduino the instructions to do with the things it's reading up here in the higher part of the loop, and all of that information is given to it. It's learning it from this capacitive sensor.h library. So here's the next set of code for our second capacitance experiment. It's almost exactly the same as the first, except we're declaring the thresholds as variables instead of direct numbers in the loop. So I've created three different thresholds, three different numbers, that I can just change up here once to find exactly the right levels for those thresholds. I'm going to give this a quick upload so that we can then check it out in the serial monitor, which again is in the upper right, or you can even have a little bit more fun and check it out in the plotter. And so here's the numbers that our Arduino spitting back out. This is literally what it's sensing from these pieces of foil. So as I touch one, we'll see one spike very high. The other two will also spike. Same with that one. You'll notice that one's a much larger spike because that's the 10 mega ohm resistor versus the 1 mega ohm resistor versus the 4.7 mega ohm resistor. You see how the 4.7 is almost exactly half of the 10? A little bit, a little bit under half. That's because it's 4.7 mega ohms versus 10. It's just under 5. So it's sort of proportionate to the resistance of the resistors that you're using. So that number, that range, is much bigger with the larger resistor, giving us a little bit more play with where we set our thresholds, which is why larger resistors make this a little bit easier. It also lets you do things like sense when you're just above it. So you can kind of see that the red line's slightly rising because that is me hovering my hand over it versus actually touching it, which lets us do a couple of interesting new things. So as you look at this, you can watch it directly and see where the numbers are in the chart. You can look at the serial monitor. We've got 3 rows of lines here, our threshold 1, 2, and 3. So using your hand, you can see where the numbers kind of hover around and start to set these numbers up for your thresholds as you see fit. It's going to change dependent upon everything from the ambient humidity to how big your piece of foil is to how big your resistor is. So play with these numbers. They may not work right out of the box with my code because your particular circuit or situation might be a little bit different. So look at the numbers, find which numbers work, and exchange those for thresholds 1, 2, and 3. A number that it passes when you touch it and goes back under when you let go. And let's see how setting these to a very fine-tuned number changes how we can operate this in a little bit. So here we have the exact same circuit that we were working with before, except now I've put this kind of scrappy piece of plexiglass over my foil, so I won't be making direct electrical contact. But because capacitance is measuring my electric field, and that electric field extends beyond my body a little bit, and the sensor can pick that up, I don't actually have to make a direct electrical connection. I can be transmitting my capacitance through the plexiglass, which this gives you a few interesting different options with how to interact with your objects. So the circuit's the same, and I've been able to fine-tune these numbers with the second piece of code utilizing variables instead of direct numbers in the code. So I can watch this in the serial monitor as I touch each one, find the right numbers, plug those into the threshold variables, and I'm all good to go. So have fun with different materials. It doesn't have to be plexiglass, it doesn't have to be see-through. This could be anything that's non-conductive. A piece of leather, a thin piece of wood, paper. Use your imagination, have fun, and email with any questions.